Hi everybody and welcome to AP Macroeconomics with Mr. Farmer. Today we're going to talk about economic growth and where that typically occurs. Now before we talk about that, we're going to do some practice. So here we're going to try and figure out how to calculate the price index, figure out the real GDP, and then we're also going to start looking at how the real GDP could have been changing. So I did practice one for us. So we're going to take the value of the market basket, this $500, and we're going to divide it by the value of the market basket of the base year, which I just put as BY. So 500 divided by 750 times 100, that's just the equation, equals 66.7. Then to go from the real GDP, we're going to take the nominal GDP of 1,000 divided by the price index in hundreds, and that's going to get us our GDP. So go ahead and try the rest. Pause for a second if you need to. And then here are our answers. So we can see we get price indices of 66.7, 100, and that's my base year, 200, 300, and 400. So then to get the real GDPs, you can see what's happening here. So what's happened in productivity? Well, from year 1 to year 2, our real GDP has increased, so there's more stuff produced. Since the prices are held constant, we just know that's not because of that, so we know it's going to be because of those actual increase in goods and services. From year 2 to 3, there's a decrease in productivity, there's a decrease in actual output, hence a decrease here. For the rest of them, simply more final goods and services were produced in the given year. So looking at economic growth, what is it? Economic growth is an increase in real GDP occurring over some time period, usually a year, but could be other things. An increase in real GDP per capita also can occur over some time period. Both these are used for economic growth. Sometimes you want the per capita or per person. Sometimes you just want the total number. The real GDP per capita is found by simply dividing the real GDP by the size of the population or region or whatever it is you're talking about. That would then identify the economic growth. Again, we want to talk about the real GDP, so we only focus on the actual output of goods and services, and we don't have to worry about the prices and the inflation. So you can see here's the map of the United States in 2014. You look at the percentage change in real GDP by state, and this can be very telling as far as how things worked out. So you can see places like California and Oregon and Texas had really high growth rates, and some places like Alaska have negative growth rates. And so how much was produced, what's going on there, the growth rates tell us a lot. Whereas if you look at just the numbers, well, California's going to have the largest economy because it has the largest economy by compared to all the different states. But as far as growth, does it produce more? That's why we look at the real GDP, and also we're going to be focusing on the percentage change in real GDP eventually. We can do the same thing with the world to see how it is working. And again, a later conversation is going to be, how much growth do you want? Do you want a really high or really low amount? You can see some places, the darker colors have very high growth rates. Some have 0, that could just be no information found. And then a lot kind of have this 1 to 2% range. And which is good, which is bad, it depends on the country. Typically places like the United States want around 2%. In 2018-19, places like India and China wanted 6 to 7% was the country's goal for growth. Why? Because that's what was needed at the time. So every country has a different value. It's not a universal number. So how do you find this? So finding per capita growth, we're going to do new minus old divided by old times 100. So for finding the per capita growth, specific minus base divided by base. So for real GDP, what you're going to do is, if you're looking for the between 2 years, usually you look for percent growth. You do go from year 1 to year 2 to year 3 to year 4. It's not always referencing the base year. So the real GDP per capita in 2004 was 36,596, and the next year was 37,536. You simply plug in for that equation, and you find there was 2.6% growth per capita in whatever this country was. And so the GDP per capita, you can see sometimes it's very telling and sometimes it can also be misleading. Usually places that are smaller countries, Qatar, Luxembourg, Macau, Liechtenstein, typically are higher numbers simply because they're smaller countries. Not always, you do get some other ones on there, but that's something to consider whenever you look at stats, data. What is the number telling us? What's happening here? And does it tell us what we think it's telling us? Okay, because if I look at the GDP, the United States in 2015 was the top with 18 million, and then China and Japan, everything else. If you adjust for purchasing power, called GDP PPP, China actually currently has the #1 real GDP adjusted for purchasing power, real GDP PPP, and so that can change some things. Okay. So when do you use one over the other? Well, according to most, when you look at things like real GDP or overall just GDP, you're looking like how good an economy is doing from like a military political concern, how much is being produced. If you're looking more for like standard of living, you're going to look more at the per capita. For us in our class, we'll just use whichever one is being referenced, which is typically going to be the GDP or the real GDP. But again, numbers can be misleading. So according to our textbook, China's real GDP in 2004 was $1,938 billion. Denmark's, smaller country, in real GDP in 2004 was $220 billion, almost 1/10 the amount. So according to this, China seems to be doing better. But if you do the GDP per capita, it's a different story. China's real GDP per capita drops to 1,500 and Denmark stays at 40,750. So again, each number tells us a different story. One thing you want to talk about though is, does the US dollar, which is what this is based in, how much can that buy in China versus Denmark? Okay, that's something else to consider. So again, these are numbers, they're definitions, and just know what they say and know what they don't say as well. So for instance, if a population has an increase of 1.7% real GDP, that's not great, but also not bad. Again, the United States is typically around 2 to 2.5%, so it's a little low, but it's still okay. But if the population growth is 3%, then the real GDP per capita has shrunk. So when do you use one over the other depends on what question are you asking. That's all. So economic growth, why is it important? First off, it's an economic goal, a pretty standard one for most countries. That's because you're better able to meet people's wants, meaning you move away from the needs and you can actually go to the wants. Do you want food or do you want your choice of food? Do you want clothes? Do you want your choice of clothes? Or whatever else it might be. It might be able to raise real wages and income since there's more surplus. You can actually push that onto everybody else, which is always good. You can also create programs to help others. If it's a welfare program, if it's an international financing type program, microfinancing in some cases, you can go to that is the idea. Okay, you can help out with poverty, environmental issues. That is one reason why it is a main goal of economies. And something you can consume more since it continually creates more. Again, more and more people say, it's a consumer-led world out there. Well, there's just more stuff being able to be produced and people have more access to it. So it just kind of makes sense that way. So where does this growth come from? Well, a couple places. One is it's an increase in inputs of resources. Growth is, can you produce more? Well, if you have more resources, you can produce more stuff, which makes sense. Do you increase productivity of those inputs? So have the machines become faster? Can you be more productive with that? Productivity is output per unit of input. So if you have one person that can now, with assistance of machines or capital, whatever else, do 2 or 3 times what they used to be able to, that works out. Agricultural farming machines, what used to take 100 man hours, quite literally, now takes half an hour with harvesting machines. Well, that's a pretty large increase in productivity. One person driving the machine can now do 100 people's hours. Okay, there's a huge increase in productivity there. Okay, Now, how about considerations of growth? What else can we have? How about improve products and services? Again, these are things that we realize are not part of the GDP, that they're not reflected in that, but we do get increased productivity, increased services, since there's only one person in that machine to do the agricultural. Maybe there's other people to do more marketing or customer service. Overall, the economy might have added leisure time, again, something else not reflected in the GDP. Environmental impacts, again, not included in GDP, but maybe that's improving because it's more efficient with that. If you want, look into a thing called Taylorism, a guy from quite a while ago who talked about how to get stuff faster and faster. In fact, when you start looking at how everything is run these days, especially if you look at things like fast food restaurants, they all kind of go with Taylorism. Is it efficient use of resources? It's still used today, even though it's a concept from a while ago. Last thing is this: how long will it take to double an economy? We have this thing called the rule of 70. If you've known math, you've heard the rule of 72. It's pretty much the exact same thing. We're going to use 70 as the number. So this concept is a geometrical equation, but we simplify it down. It tells us how many years it'll take for a country to double in whatever you're talking about. In this case, double its real GDP. So it's an approximation because it assumes that this is a standard consistent number. So you're going to take the number 70 and you're going to divide it by the annual percentage rate of growth. Whatever your outcome is the approximate number of years it's going to take to double the GDP. So an example, if you have an annual percent growth rate of 3%, in a pinch, you can use inflation. There is some correlation there, although if you can, don't do this. But if you're given those numbers, you're given those numbers. So 70 divided by our 3% growth rate means this economy would double in the next 23 years, assuming a consistent 3% growth. So if you have an annual percent growth rate of 7%, how long do you think it will take to double? Go ahead and try it. 10 years. Now this goes back to what is a good growth rate? How much do you want? And this goes into how fast do you want to double an economy? And the risk goes into infrastructure. Can you double your business in your economy in 10 years? Can your roads deal with twice as many trucks? Can your internet compete with twice as much? Or do you need to slow it down? This might be why some countries have things like they want 2% growth rate, so they'll double in the next 35 years. Versus 7%, can you double in 10 years, and is it safe to do that? That's why some of those numbers work out. So this can be used as a planning. Okay, how far in advance do you want to go? Can you handle this for infrastructure and whatever else it is? So sometimes that's where those numbers come from, is this concept. With that said, it really isn't consistent as far as is it always 3%? No, sometimes it's more, sometimes it's less, so it's a ballpark figure here. If you want, you can go more into this. This is the math behind it. I know Khan Academy talked about this, so we don't need to know all this, but I know some people really like that, so it goes into natural logs for the equation. So if you want, you can look into it. We don't need it though. So overall, we talk about what is economic growth, why we use real GDP, and what are growth rates, where does the growth come from, and then also what is this rule of 70 as far as how many years does it take to double. All right, that's it for today. Until next time, bye.